Hi, in the last video, I discussed about how do we use chi-square goodness of fit test to check to test whether the observed frequencies follow the certain assumption, okay, or certain given frequencies that we call expected frequencies, right? So that's what we did. But the chi-square test can also be used to check whether two categorical variables, they are independent or not. Okay, whether one variable depends on the other categorical variable or not. Okay, so so the idea is the chi-square independent test is also used to test whether two variables are independent of each other. We use the same chi-squared formula to find the test statistic. Is exactly same. So summation of observed minus expected whole square divided by expected, right? And to find out the expected frequency, we use row sum times the column sum, and then divide by the grand total. So how do I find out the row sum? So these sum of these three are the row sum, the first row. Sum of the second row is second row, and then you find out the column sum too, and you find out the total of the total. You add all these three items will be give you the total of the total. Okay. So the degrees of freedom, we use row minus 1, number of row minus 1 times number of column minus 1. Okay, where R is number of rows and C is number of columns. You always use a right tail test again. So the note is the method involving contingency table. This method is called contingency table. Okay, require each cell to have expected frequency at least 5. So if the expected frequency of these are the observed frequencies, okay. If the expected frequency is bigger than 5, less than 5, we either remove that or we do we combine that with the nearby. We combine that with the nearby column. Okay, that's what we do. Okay, so let us see this. So example. Suppose a new post-operative procedure is administered to a number of patients in a large hospital. The researcher can ask the question, do the doctors feel differently about this procedure from the nurses, or do they feel basically the same? Note that the question is not whether they prefer the procedure, but whether there is a difference of the opinion between the two groups. Okay. To answer this question, the researcher selects a sample of nurses and doctors and tabulates the data in table form as shown. So see, there were 100 nurses who prefer the procedure, 50 doctors prefer the procedure, the new procedure, and then 80 nurses prefer the old procedure, 120 doctors prefer the old procedure, and then no preference. They say both are okay or both are whatever they say. Okay, so there is no preference of one versus the other. There are 20 nurses and 30 doctors. So you want to test whether the opinion about the procedure is dependent of the profession, independent of the profession, or dependent of the profession. So H0 is independent of the profession, meaning they think the same. Okay, it is not depending on whether many nurses, whether the certain professor has preference on certain method or not. That is independent. But certain professionals have preference on the certain procedure is the dependent. Okay, so that's what we do. So what is the degrees of freedom? How many rows? 1, 2 rows and 3 columns. So 3 minus 1 times 2 minus 1, right? Because see, R minus 1 times N minus C minus 1, you got 2. So the critical value is alpha equals 0.05, and right tail test is, so it is the critical value. So you don't need to worry about the critical value. We will be finding the test value and we will be finding the the test statistic, okay, by finding the expected value. So no worries about that. And if you want to know that, you will be using the chi-square test, right chi-square test with alpha equals to 0.05. When you look at the right area of the 0.05, you will get that degrees of freedom is 2. Okay. Now, the test value is, first we find out the expected value. How? Row sum times the column sum divided by the grand total. For example, if you want to know what is this expected value there, how do I find out that expected value? What do? What is the row sum? This is the first row, right? See, the row sum is 200, right, times the column sum is 150 divided by the total of the total is the sum of the last row or the sum of the last column is 400. Okay, so if you cancel this 0 with that 0 and this 0 is that 0, what do you get? And then this with this 5 times 15 will be 75. That's how you get that 75. Similarly, to find out that for 50, what is the expected value? You want to find out that, okay? To find out that, what do? What is the row sum? Sum of those rows there is 200 times what is the column sum? Is 150 again. Divide by, you see what? You see the total of the total is again 400. So equals to 75. In this case, it is likely that you will get the same values for same expected value for each column. See, you do the same thing for here, you do the same thing for here, right? Now, so these are the expected values. Expected value, expected value, expected value. So to find out the chi-square, what do? Is chi-square equals to summation of OI minus EI, this minus that square plus this minus that square plus this minus, because these are the observed, these are the expected for each of those, right? So you got 26.667. Now, always using the right tail test, so for the p-value, you do 1 minus p chi-sq and 26.667 comma 3. Okay, and you do 1 point, that is very small value, you see that? So p-value is less than alpha, so we reject the null hypothesis. We reject the null hypothesis means you are indirectly supporting this one, right? You are supporting this one, meaning there is the opinion about the procedure is dependent upon the profession. That's what you found here. Okay, guys. So let me see if I have the one example in the this example done in R. So if you are doing the test of independence using R, the very first thing you need to do is you need to type, okay? So you need to type the observed frequency in Excel file, Excel sheet, okay? So let me find out where is my Excel sheet here. So what I'm going to do is, let me find out that that's the independence 1 XLC. Okay, not this one, not this one. Let me see, there is independence 0 XLC. Okay, so what I did here is I entered just the name, nurses, doctors. You don't need total. And then you need prefer the new procedure and prefer the old procedure and procedure, and then no preference there. Okay, so after you do this, you should save it. Go to file and then save as. Click that, and then you save as a CSV because R likes CSV more. See, I have it saved already. That's why it says replace it. I replaced it. Okay. Now, whenever I save that as CSV and whenever I replaced that I just saved, see? So it is removing all the unnecessary blank rows and column before and on the above and on the left. So it started from very beginning. You see that? This is what the saved file is. Now what I want to do is I want R to read that file. Okay. So how do I read that file? First of all, what you need to do is you need to find out that file on here. Okay, but where is that file? So you can save that file in a folder in your computer and then access that file from here. Okay, you can go here, click that three dots here, and then you will be able to find out where is the desktop. And under the desktop, I have like that data file is hidden so inside that I will have to go to teaching on spring 2021 math bio, and then biostat, and then go to introduction to biostat and computer R course, biostat R course, and then there is a data. And if I open this, that folder, all the file on that folder is opened here. Okay, so I have shown you how to do that already. But what was the name of the file, Excel CSV file? That was independence 0.csv. I click that and go to import dataset. Just select that, and then what I do is I just copy this, Control C, and then cancel that, and instead of reading that, I just paste it. Okay, Control V. Okay guys, and then header equals to true, because it will consider the header as a header of that. Otherwise it will consider that as a data, so it will show you error. Okay, now let me run that. Let me make it a little smaller, and then let me make it a little up here. So what I want to do is I want to clear the console first. Okay, so what I did here is I am running that file, and then let's do A. Look at this. So the nurses and the doctors, this is so prefer new is 150, prefer old is 8120, and no preference is 2030. Okay, now what I want to do is so the R will think these are basically the header, but we didn't tell these are the row header. We just told these are the column header only. Okay, so what I want to do is I want to pick just this data, not that doctors and nurses. How? Look at that. A, rows are first and second. So R is not taking that as a data. This is the header, because we did header equals to true there. Okay, so this is the header, but R is thinking this as a data, this as a data as well. So this is the first column, second column, third column, and fourth column. R is taking that, but for the row, R is taking this as the first row and second row. See, what I'm doing is I'm picking first row and second row, but for the column, I'm picking second, third, and fourth column. Second, third, and fourth column. That's what I'm doing. See, whenever you are picking a sub matrix from the given matrix, you can do bracket there. If I run these, this is what I got. B. See that nurses and doctor, that is removed. Now what I do is to test whether the you see that whether the opinion about the procedure, these are the opinion about the procedure, depends on the different profession or not. That's what we were going to test. What you do is you do chi.test and then just that B. If you do that, then it will give you the p-value is 1.62 times 10 to the negative 6. So 1.62 times 10 to the negative 6. So if you do it by hand or you do by R, but R is a lot easier, right? So if you're using R, you need to type the observed data with the title in an Excel file and then save that as CSV, and then you read that file by copy and paste the path there. Okay, and then you need to remove the name of the row. So because these are the first row and second row, but the name was included on the first column here, right? That's why I removed the first column, which is the row names, and then just displayed only the real data. And you do chi.test. That's what you do. Okay, guys? So that was example from slide 12. Let me go to this slide here. Okay, so on this slide, again, we'll do the same thing. And whenever you try to enter that thing in the Excel, you don't need the total again. Okay, so you'll need to enter only these things. Okay, let me read this question and then I will show you again how to do that in R. All right. So what it says is a species of parasite trematodes uses 3 hosts during its life cycle. Worms mature in birds and lay eggs that pass out of the bird on its feces. The horned snail eats these eggs, which hatch and grow to another life stage in the snail, sterilizing the snail in the process. When an infected snail is eaten by the California killifish, the parasite develops to the next life stage and insists in the fish brain case. Finally, when the killifish is eaten by a bird, the worm becomes a mature adult and starts the cycle again. Researchers have observed that infected fish spend more time near the water surface, where they may be more vulnerable to bird predation. Researchers tested the hypothesis that infection in fish influences risk of predation by birds. A large outdoor tank was stocked with 3 kinds of killifish: healthy, lightly infected, and heavily infected. The tank was left open for birds predation. The following is the observed data. Okay, so in one tank they put uninfected, in the other tank, second tank, they put lightly infected, and in the third tank they put highly infected fish. And then they count how many were eaten by birds in each tank and how many were not eaten by birds in each tank. Okay, there were total 141 fish. Okay, if you want to do by hand, then you will have to find out the expected value for each of these by row total times column total divided by the total of the total. Row total, column total divided by total of total, and so on. You'll have to do that. And then if this expected frequency is less than 5, you'll have to combine to the other one. Okay, we'll see that. So what I'm going to do here is I am going to do in R. So let me check if I have saved that independent second example here. See? So this is that what I have typed in Excel file. So uninfected, okay, uninfected, infected, and highly infected, lightly infected, highly infected, eaten, not eaten. You see that? Now I save it as a CSV file, and this is what I got when I save it as a CSV file. Okay, you see that? Now what I'm going to do here is, it is already in the same folder. You see that? This is the independent one.csv. What I'm going to do here is I am copying the path of that file, and I will post it here. Okay. All right. Now what I'm going to do here is I will run this. That was a warning message. No worries about that. So here, what is happening here is uninfected, lightly infected, and highly infected, eaten and non-eaten. Again, you need to remove that first column because this is the name. This is not the data. So what I'm going to do here is B equals to A 1 to 2, 1 and 2 first and second rows, and then 2 to 4 first, second. Oh, this should be 2 to 3 first. Oh, I'm sorry, second, third, and fourth, right? So second, third, and fourth. So it should be, we are good. Now if I run these, that is B. You see that? Now you see that, I mean, you can check what is the frequency expected value for this. I can check it as, so what was the row sum? Row sum was 48 and column sum was 50. So 48 times 50 divided by 141. Let's see that. So 48 times 50 divided by 141. If I do that, what do I get? Oh, I got 17 points. So I don't need to combine. You see that? I got 17.0212 here. The expected value for this will be 17 points. So it is not less than 5. So we don't need to combine. So I'm not combining that, okay? So I'm not doing that. So is there any other cell that may have less than 5? You can check. I mean, So what will be this one? What will be the expected frequency for this one? You will have, what will be, what do you have? You will have the row sum is, again the row sum will be for 10, the row sum will be 48. This is 48 times 45, right? Let's try that. So 48 times 45 divided by the total of the total is that. So it is 15. So none of them are. So I was not checking that way, okay? So I am removing that. So what I'm going to do here is chi-square test of B. Okay, so let us do that. So that is B. And then if you do the chi-square test, you got p-value is 4.106 times 10 to the negative 7, which is p-value is less than alpha again. So the infection risk is, so we reject the null hypothesis, right? Because what was the alternative hypothesis? The alternative hypothesis is the infection risk is independent. Okay, so the infection risk in the bird is, or you can say that this is the predation, right? So the predation is independent of the infection level of, so the null hypothesis is the predation is independent of the infection level of the fish. The alternative hypothesis is the predation is dependent on the infection level on the fish. That was the alternative hypothesis. So, but we got p-value is less than alpha, meaning that the predation is dependent actually, right? Dependent on the infection level on the fish. Okay, so let me do one more example there. Okay, so what I'm going to do here is I am taking a built-in function or built-in data set there, and then I will have a big data set there, and I will form a table that we saved in the Excel. But you don't have to here, okay? If you have the real data, then you don't have to save that, so you can basically work from there. Let us try that. So to do that, you should do library mass and run that one. Okay, so survey data is, what is survey data? Survey data is this data frame contains the responses of 237 statistics 1 student at the University of Adelaide to a number of questions. So see, there were gender, there is span, so the sex of the student. The next variable is WRHND, means span, distance from tip to thumb to tip of little finger. So they have measured so many crazy things. Okay, so what they did is, when they smoke, they are studying the smoking behavior. Okay, so what is the distance of the tip of the smoke from the hand, and then span of non-writing hand, whether writing hand or non-writing hand. W hand means writing hand of student, not writing hand. Okay, fold, pulse, clap. So there are so many variables and so many other things. So what I'm going to do here is I'm going to display that data. Look at this. I think there are 83. Oh, there are more. 154 plus 83. That is 237 students there. See, these are the variables. Okay, gender, WR hand, and all those kind of things. So what I'm going to do here is I'm going to make a table. So A equals to table and the parenthesis. This is the whole name of this data set, survey. I'm picking the smoke and then picking exercise. Okay, I'm making the table for smoke versus exercise. Okay, survey smoke means it is going to do the table for survey and smoke. Survey and $ exercise means, so it is putting both things in the same table. Let's see how it looks. Look at this. So heavy, never, occasional, and regular smoker, and because the first one is smoke, and the second one is the exercise, frequent exercise, none, and then some exercise. Okay, so this is what he's doing. Now we want to test whether the smoking habits is depending on the exercise level or not, or you say whether the exercise habit or the exercise level depend on the smoking habit or not. That's what you want to test. Okay, look at that. Some of those are 1, right? So how do I find out the expected frequency by hand? You will have to do, for example, if you want to find out the expected frequency for this one, what do? Row sum. is, what is that? 7 plus 1 plus 3 is 11. Column sum is 1 plus 1 is 2 plus 18 is 20 plus 3. So 11 times 23 divide by 257, right? What do you get? So 11 times 23 divided by 257. That is the total number of students, right? So this is less than, even less than 1. So which is less than 5. So we need to combine the columns. If the expected frequency, if you doubt any of the expected frequency is less than 5, you can actually calculate by row sum times the column sum divided by the total of the total, and then find out that if it is less than 5, then you can combine. Look at this, what I'm doing here. Since at least a cell has small frequency, okay, we next combine the two columns. How do I do that? Is, look at that. So you do C equals to C bind, means column bind. What column are you binding? You are binding the column of the frequency column. Frequency column is just keeping that because they have the bigger numbers there, right? And then B non, this column is binded with that column because this also has a smaller number, right? So you bind, see how did I do that? It will keep the value of those, it will keep the structure of those, okay? It will keep those values. So what we are going to do here is C bind B frequency, comma, another column will be that, the sum of those, that is non plus sum. Let me bind those. Oop, what does it say? Undefined column selected. Oh, let me see, what did I do there? So B is that. Oh, I did not run here. Okay, let me run from the beginning. Okay, so that's what the table is. Okay, A is the table. Dimension of A is 4 by 3. B is 1, 2, 3, 4. And then column is first, second, third, fourth. So we are just ignoring the first column. So it is 1. Oh, by the way, that's a very important thing, okay? So see this, whenever you do the table from R, it will consider this as a header and this as a row header, this as a column header. So no worry about skipping that. That's the important thing I forgot to mention, okay? If you are making a table by R directly, so I'm taking 1, 2, 3, 4 rows and then first, second, third column. It will take this as first column, second column, third column, because when you are making a table by R, it will consider this as a row header, okay, like it consider the column header. So if you do that, and then you got B equals to that, right? Now I want to bind the second and third column. That's what I do. And let's see whether it bind. Look at that, it bind. It keep the same row header though, right? Row header is same, column header is same because we are combining those two, okay? Now we want to do the chi-square test for this. Let us do that. If you do the chi-square test, you got the p-value is greater than alpha. So the p-value greater than alpha means you do not reject the null hypothesis. So what can you say about that? If p-value is greater than alpha, do not reject the null hypothesis. Hence, the smoking habits are independent of exercise levels. Okay, guys. So this is how we test the independence of variables by using chi-square test. Thank you.